All right, well, we're still talking about assignment 8.1, what is normal, but we're going to start in here on problem 10, which says, what does the standard deviation tell us about a distribution? Now, to figure out the answer to that question, we're going to look at several distributions. So notice part B says each of the distributions shown below are normal distributions with the same mean but a different standard deviation. So here we have our three pictures. Notice that on each picture the mean is equal to 3. Now remember that the mean is the average value. So our average value is 3, but our standard deviation changes. In the first picture it's 0.5, second picture it's 1, third picture it's 0.25. Now your job is to look at those three pictures and tell me what you notice is changing. Hopefully you notice that the smaller the standard deviation becomes, the higher and pointier the peak. Remember that standard deviation is a measure of spread. It tells us how spread out the data is. So if we have a big standard deviation, that means our data is really spread out, like this, as opposed to having a small standard deviation, which means our data is not very spread out at all. Instead, most of our data kind of sits together right here in the middle. So when we change the standard deviation, notice that it tells us how spread out the data is, so I'm going to put down that small standard deviation equals not much spread and a tall peak in middle. As opposed to a large standard deviation, which gives us lots of spread and not as tall of a peak. Okay? So now we're going to look at this next question, number 11. What does the mean tell us about the distribution? Now remember that the mean is the average. And again, we're going to look at some pictures to see if we can figure out how that mean affects our normal distribution. So here, each of the distributions shown below are normal distributions with the same standard deviation, but a different mean. So notice in our first picture, the mean is 1, and the standard deviation is 0.25. Next picture, our mean is 2, but the standard deviation is still 0.25. And on the next page, the mean is 3, and we have the same standard deviation. So if you look at these three pictures, hopefully you'll notice that where that mean is tells me where the middle of the peak is. So that's causing my graph to shift left or right. Notice that the curve is the same. All that's happened is it's moved left or right. So when we change the mean shifts the graph left or right. And it has that effect because notice how the mean is the middle. It's where this peak is the tallest. So changing the mean shifts where that tall peak is going to be. Now that we figured out some of these features, we're going to go through these last two statements. So question A, a normal distribution depends on the mean and the standard deviation. Well, remember that the mean is what shifts us left and right, and the standard deviation tells us how steep or not steep our peak is going to be. So this is definitely going to be true. The reason is because the mean moves it left or right, and the standard deviation tells us how tall to make the peak. And I'm just going to shorten that. Okay, question B, the mean, median, and mode are all equal in a normal distribution. Well, if we look back at these normal graphs that we were looking at, remember how when we were normal, we had right here the mean, median, and mode were all smack dab in the middle of our normal distribution. So here on this question, It says the mean, median, and mode are all equal in a normal distribution. Well, that's true, and we know that by definition of what a normal distribution is, but I'm going to say because of example 2. Okay, because that was the example where we saw that in a normal distribution, the mean, median, and mode are all equal. Question C, a normal distribution is bimodal. Well, remember that bimodal is that graph that has 2 camel hump peaks. And that's definitely not a normal distribution. Okay, so for y, I'm going to say a normal distribution has only 1 peak. Because remember, it's that nice bell curve shape that we want to get with our normal distributions. The last question, in a normal distribution, 50% of the population is within 1 standard deviation of the mean. Now, do you remember how a few minutes ago we looked at that example that had the percentages in it, and I told you the percentages would be important? Well, let's look back at that example and the percentages. So, here's our example right here, and smack dab in the middle, remember, is where we have the mean. Now, each of these little lines represents 1 standard deviation. So I can go 1 standard deviation up, or I can go 1 standard deviation down. And it tells me that within this 1 standard deviation up and 1 standard deviation down, we have 68.26% of our data. So remember, the question asked that in a normal distribution, 50% of our data lies within 1 standard deviation. Well, it's actually 68.26% of our data that lies within 1 standard deviation. So this one, it kind of depends on your interpretation, but I'm going to mark it as false. And for y, I'm going to write down that approximately 68% of our data lies within 1 standard deviation. Okay, well, once you know that about your normal distributions, you're ready to go ahead and try this last page. So go ahead and try the last page on your own, then tune into my next video, and I'll talk about it.